Machine learning is very easy in MATLAB. MATLAB has lot of inbuilt libraries and toolboxes which makes machine learning tools very easy to use. So let us try to understand how to build a machine learning model in MATLAB step by step. Hello all, welcome to our YouTube channel. We will be continuing our series on MATLAB functions. The topic is machine learning. Before going to depth of machine learning, we shall understand one basic question: why machine learning is important? Why machine learning is required? Any system whose model can be represented in terms of mathematical model, those system does not need any machine learning model or AI model. For example, there is a box and you are applying a force F and its acceleration is A and mass of the block is M. If somebody asks you to do a machine learning model for this force, output force equation, is it really necessary? No, because this system can be easily represented as F is equal to ma. You can write the mathematical equation of this system. So there is no need of doing a machine learning model for this system. For same system, for example, there is a force F1, there is a force F2, and there is a force F3. And this object can move in A1, A2, and A3. And there is no relation between F1, F2, F3 to A1, A2, A3. Then in this case, you cannot directly write a mathematical equation. So for this kind of systems, machine learning model is necessary to predict what is the output for the next set of data. You're getting the point? So any system whose mathematical equation cannot be written in simplest form, then you need a machine learning model. Let us try to build a machine learning model in MATLAB step by step. So first step is data collection. What is data collection? Data collection is a step where you generate data from any of the inputs for your system to train and test your machine learning model. So the preparation of data for your machine learning model is called data collection. So for your system, whatever the input hardwares are there or input systems are there, from that the collection of data or generation of data is done in this step. Without data, machine learning model cannot be generated for any system. So this is the first and important step in machine learning model generation. Second step, data processing. So data processing is nothing but in your data there might be n number of data which is not eligible for your training the machine learning model. What does that mean? You have some data like this, and then for this kind of data you want to build a linear model. What this linear model will do, it will try to get a straight line equation for this number of points. So wherever maximum number of points is covered, so that line is selected and drawn a straight line. So this kind of straight line is drawn. So for this, some of the inputs are very close and some of inputs are very far away from the model equation. If you consider this data for this model generation, then straight line equation can go in this direction. This may not be accurate compared to this straight line equation. So that is the reason data cleaning is very important. What is the data processing or data cleaning step is removal of noise data from your data collection or from your data set. That is called data processing. Next step, feature selection. What is this feature selection? Feature selection is nothing but what kind of information you want to use it from your existing data to produce your model much more accurate. Let us try to understand feature selection with a simple example. SOC prediction using voltage and current. For this, if you have data like this, via RMS voltages, RMS current, average voltage, average current. If this kind of four informations are available, what is that information you want to use it for SOC prediction? Do you prefer RMS or average? Generally, RMS voltage will have lot of fluctuation. Average will be average of the waveform. So this will be having lesser fluctuation. This will have lesser noise compared to RMS. So it is better to go with average values than RMS. RMS is a type of feature and average value is type of a feature. So if you are trying to produce more and more feature for the same signal, then it will give better and better accurate models. So that is the advantage of producing the feature, and extracting those feature is called feature extraction. So this way average is there, and if you are trying to use information like mean and min max values, so that is also a feature, and then standard deviation, so that is also a type of feature. More and more information will help your model to get good accuracy. So now let us go to MATLAB and try to import a data. So there is a data available with me where data looks like this: voltage, current, temperature, and SOC is my output. So target is using voltage, current, and temperature as a input parameter. I have to predict SOC, that is my target variable, output variable. This is how our data looks. If you see, there are so many data, around 500 samples of data. With this 500 samples, we'll train the model and we will try to get the output for this SOC prediction model, right? So let us go to command window. Here we'll give input variable x. First three columns of that x is our input. So that is generated. Sorry, I have used only three, so it should be 1 to 3, right? So these are the inputs: voltage, current, temperatures. This we have selected. And now y will be data of 4. So output variable y SOC is the final target table. So we have collected the data. Data generation is done. Do we have to do data processing and feature selection? Yes, we have to do, but with our data set, it is already, the noise and things are already available. Let us try to predict this model with whatever the features are available. So what are the features we have in this? We have voltage, current, and temperature. Direct values will take it as a feature. If you are going with more and more features, model will be accurate, but the amount of time taken to train that model will be also increased, and the model memory also will increase because of this complexity. So we'll try to build one simple model, and then we'll try to explore the other option in other upcoming videos. Next important step is partition of your data. What we are doing is, if you have 100 data, in this 100 data you have to split this 100 data as 70 and 30. So 70% of your data goes you to train the model, and 30% of your data goes to testing the model. First train the model, and then with the remaining data test the model and improve the efficiency of that model. So that is the reason you need to split the data into 70/30. 70/30 is the ideal form of splitting the data. Now let us try to do it in similar fashion. Already we have the data, and then we have chosen the input as voltage, current, and temperature. Now we will try to partition the data using a simple statistical function called CV partition. So this is the code. CV partition size x comma 1 means x is the input function which you are partitioning, and then old out is a statistical function, and then point 0.3 is 30% of your data you are holding for testing. That is what this syntax stands for. CV is partition. Now if you try to see the CV, how does it look? We'll just click and open. It's a model workspace. You have a number of data. If you see, train size is 350 and the test size is 150. To double click the train data, you have the value 350, and then test size is 150. That is how it has done the partitioning. Now we'll go to command window again. Now we shall try to partition with this function, training of CV, and then all columns of input has to be chosen. So we'll just press enter. So 350 rows have been selected for train. So that is how we have partitioned. Now we also have to partition the output, right? So y underscore train equal to y of this is done. Now similar will also use the remaining partition for test data. How you will do? Just similar fashion, x underscore test is equal to comma all rows. Selected? Yes. Next. So 150 samples of test data is also classified. Now what is the next step? So next step is very simple. Just train the model and then test the model. Training is done. We have done the classification. Then we'll go for training the model. We'll choose any simple network model. For example, if we whatever machine learning tool is available in MATLAB, we'll try to use any one of them, and then we will try to train that used model and we'll get the output for that predicted model.
Stay tuned for part 2.